Hi, this is Professor Pradyot. Okay, so we are starting with new interesting topic, chemical kinetics. Wow, obviously you must have started wondering how come kinetics in chemistry? Because we have learned that during physics. What is kinetics? Study of motion, right? Basically, we try to study how basically any body is moving. Okay, acceleration, velocity, force, etc. So how come kinetics can be applied in chemistry? Yes, definitely. Obviously, you must have guessed now that we are talking about basically the velocity of the reaction or the speed of the reaction. Okay, so basically we try to study the rate of chemical reaction. Simple in chemical kinetics. So obviously, what kind of a speeds we can think of? There are probably we can look into three kinds: very fast or fast, another extreme very slow, and midpoint or midway it is basically moderate. So let's look into, so what will be those example? Very fast, like neutralization of the acid and base. Okay, neutralization or what we call titration. What are the slow reactions? Extremely slow. Corrosion. It takes years sometime. Okay. Now the question would be that out of these three, are we going to study all? No, we are not going to study all. Obviously, because very fast reaction, instantaneous, it is very, very difficult. Okay. Because these are going to take place in few seconds. Okay. While these are going to take years or months. So our focus for the chemical kinetics would be a moderate speed reaction. Okay. So that would be our focus. Okay. So that is one part of the chemical kinetics. Now, another part could be that what we are going to study, what we call a reaction mechanism. What do you mean by this? Simple. Let's say there is some reaction A, that is a reactant getting converted into B. Okay, this is the reactant and product. So is it going to take place in one single step or is it going to be in multiple steps? Okay. Surprisingly, in majority of the chemical reaction which you will encounter in organic chemistry are multi-step or what we call complex. Okay, so these are going to be multi-step reactions. Okay. So we'll be studying that, what is the importance, okay? Because accordingly, we will have to really look into what should be the operating conditions. Because majority of the reactions are carried out on the industrial plant also. So in that case, this reaction mechanism will help us in selecting the optimum conditions. Then another could be catalyst, our friend, how it helps, okay? How exactly it is going to function. So that will be basically part of the chemical kinetics. Okay. So now let's look into what topics we are going to cover. Okay. So first topic obviously would be what will be our methods of measuring the rate. Okay. For example, in some reaction, let's say there is some gas which is getting evolved as a product. Okay? Gas. So what we'll be doing? Gas as a product. So we'll start measuring the gas production because that will give us the clue. Okay, what will be the rate of reaction? There can be several, or sometime in some reaction there could be color which is changing, color change. And we have encountered this many times of using indicator in neutralization or titration. Okay. Then another topic would be basically studying the collision theory. Very important. This, okay, very important theory, which is basically helps us in understanding basically the chemical kinetics. Okay, why it is so simple? Because finally, when we talk about the reaction, it is nothing but collision of two molecules, A and B. They are colliding, and then only the reaction can take place. It cannot be that they are far apart and trying to make the reaction. No way. They need to come closer. That means they are going to collide. So that will be studied in detail. Okay, very interesting part. Then next obvious question which we need to study: which factors are going to affect the reaction? Factors affecting the reaction. Some of the factors you have already studied in the earlier standards, okay, earlier grades. For example, the temperature, use of temperature, then surface area. We have learned this, that for example, by crushing the solid reactant into powder, the rate of reaction increases. Okay. Only thing is we'll be studying it in the little bit in detail. Okay. At least. Then comes the another interesting part of this topic, that is a Maxwell distribution. Maxwell-Boltzmann distribution. Important from the exam perspective also, but more than that, it's a very interesting topic. Okay, why it is interesting? By knowing this Maxwell-Boltzmann distribution, we can figure out the effect of temperature as well as catalyst, how these two factors affect. And it becomes crystal clear after studying this Maxwell-Boltzmann. That is the beauty of this. Okay. Why we should study Maxwell-Boltzmann? Because it gives the clear-cut impact from this curve, Maxwell-Boltzmann. We can clearly see how temperature and catalyst affects the rate of reaction. We know that by increasing the temperature, typically majority of the reactions, the rate of reaction increases. Or catalyst, it speeds up the reaction. But how? Maxwell-Boltzmann will give us the clear-cut idea. Okay, it gives us a far better idea. Right. Okay. Then we are going to study the next. Just hold on. Okay. Okay. Then we'll be studying the catalysis. That means exactly how catalyst functions. That will be also getting very important. Okay. Because we know that its speed of reaction increases in presence of catalyst. But how? What is the logic? What it does? Okay, what's its role? Then another aspect which we'll be studying is order of reaction. Very interesting concept. Okay, what do you mean by order of reaction? Simple. Order of reaction means how, okay, in simple terms, how concentration of reactant is affecting the rate. Of reaction. And interestingly, we'll find that sometimes in some of the reactions, the concentration of reactants is not impacting at all. And what you must have guessed, that means it is a zero order. Yes, absolutely. Okay, that is a zero order reaction. Then we'll be studying the reaction mechanisms. What are the different kind of mechanism means? What is mean by mechanism? Okay, and why it is important. For example, there could be intermediate transition state. So if there are some other basically reagents which are going to hamper that intermediate compounds, then we should try to avoid those. Okay, so that also can be understood very clearly. Then very interesting part which is called Arrhenius equation. What it tells you? It tells me the basically how the rate constant is getting affected with the temperature of the reaction. K is the rate constant, okay, that will be studied, and temperature, okay. It looks very complex kind of equation, but we'll try to simplify it. That's the beauty of this. It really helps. How? Okay, it looks very complex kind of a equation, but it is very, very simple. And then we'll be studying pertaining to this very interesting topic, that is the ln(k) versus 1 by t graph. Okay, very important from the exam perspective also, but that's not the reason, but it's very interesting. So you can easily understand and score very well. And obviously we'll be studying the rate of reaction in detail. Okay, and rate expressions. Rate expression. Also, we'll be covering what is the half-life. You have already probably heard this term very well in physics. Okay, half-life. So we'll be studying how it is applicable for the chemistry, chemical reaction. Okay, so if you observe very carefully, this is a very, very interesting topic having a lot of practical and industrial importance. Okay, that's the reason that if you want to make a career in chemistry or chemical engineering, this topic becomes extremely important, very helpful. Okay, and besides that, it's very interesting also. Okay. And scoring. So why not to? Okay, make a. And I tried to break down into smaller kind of a chapters so that suppose at the last moment for during your exam, if you want to look only into one of the topics, you can pick up that, okay, and start. Hope this will be very, very enjoyable experience. Okay, thanks.